the Python prompts, and Jupyter Notebooks is an add-on to that so that you can actually put your code neatly in chunks. So there should be like something online that shows you on YouTube that shows you how to download Anaconda, how to download the Jupyter Notebooks. I'm lazy. I first say I want to put Jupyter Notebooks on my computer, and it sends me to Anaconda. It says you need to download this first. You can. You might want to jump and try Python because you'll not get out of this program without knowing Python.
No, Visual Studio Code is a window for Python.
Okay, that's fine. That's fine. As long as it's neat and I can like rerun your code. I think Skylar sent me something as Spider. I'm like, can you just put this into a Jupyter Notebook? It was so nasty to look at. Like Jupyter Notebooks opens it up in nice little chunks. I'll show you what that looks like in a second. Okay, so that's your pseudocode of inputs. Then what you want as your output. Does everybody have this down? Is you want y at 0, y at h, ... y at n times h, which is b. So you want all those chunks, the y values. So, or equivalently, like I had in the Excel spreadsheet, you'll want the t values and the y values. So I'm just going to put y as an approximation. So you'll have this. That's your initial condition. And then you'll have h, y at h, ... And the last one will be y at b. It will be the b. So that basically, and then you'll want to plot that and say, take these guys and then just whatever this initial condition was, you'll get a bunch of points. And if you scatter plot it and your 0.01 is so close, that 0.01 makes everything close, it'll look like one curve, like it did for Excel. And you pretty much have this point here. I'm going to put ... So like there's a whole bunch of these little points, and then you graph it. So that's what your output should look like. So what's the meat of your code? You start by, we call it initializing. Initialize W to be alpha. In Python, you have to save that. I do have code to do this, but you can also ask ChatGPT, once you're running this algorithm, I want to save this so that I can scatter plot all these values. Just tell it, and it will give you the code to make that happen. So you can't put it in an array. There's no such thing in Python, which is, it's a huge drop for me. I don't like that. Run the RK loop. A loop is just where that's the same thing when I scroll down the formula. It's just doing the same thing again and again and again. So what do you want? What I did in Excel, you want it here. Set. My first row was the K1s. K1 with it. I still have the H there, Evan, sorry. So you do just what I did in Excel. You already have W and T given to you. And then t plus h over 2 will be 0.0 t, whatever your t was. If it's 0, 0 plus 0.01 divided by 2, and you plug it into your f, just like I did. So the brute force way to do it is to put your f inside the loop, which is actually in the clean way to do this. I think Colonel Lindquist would have a heart attack, but I just want it to run, so I just put it right there. But the clean way to do this is to make a function where you can change the f to something else if you wanted to. That way the code is actually ages well. I don't do that, so I have always had to recreate things again and again. It's easier second time around. It's a developmental opportunity to do it again and again.
That's not a negative t, is it?
Huh?
That's not a negative t, is it?
Okay. No.
Okay.
Leftover. There.
Is KN1 the just T and W one?
What's that again? Oh yeah, it's T. You're right. Sorry, I was doing the second one. T comma is the K's. So this knows, because you've already initialized T and W, it knows what to do here. And then K2 would be the one I just wrote up here. H times F2, F of T plus H over 2, and yada yada. You just do all those things I did on the Excel file. Just keep plug them all in. And then step 4, inside your loop. So the biggest bugs you have is when to know that has to be outside your loop. If you put it inside your loop, you're going to have a problem. You'll know when you graph it, you'll see, oh, I have a problem. Step 4 is inside the loop, dot, 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 inside loop, update, T and W. W is going to be K1, the old W, plus K1, plus K2, plus K3, K4. 2's go here, and then divide that by 6. So you upgrade that, and then you also have to upgrade your T. What's your new T going to be?
T plus H.
Right, the old T plus H, which was 0. Let's just make it easy, make it 0. So T is going to be I times H. Right? That tracker keeps track of, like, I'm in my first chunk, it's 1 times 0.01. I'm in my second chunk, I'm 2 times 0.01. I'm in my nth chunk, I'm at the very end. So just keep having it updated. And then, unfortunately, in Python, you want to somehow store this. So you have to save this. So this is not in burden affairs. Burden affairs always has pseudo, which is really nice. But if you're looking at burden affairs, they don't have this. But in Python, you need to save in the loop, save TW. You need to save it to some kind of something like an array. I do have code for that, but what I would recommend is, step 5. What I would recommend is that you actually write the code without this piece in it, and then tell ChatGPT, I want to save these so I can plot them all. Be very explicit in how you say it. You'll get used to it, because if you're not explicit, it's going to misunderstand you, and it's going to give you garbage. And then step 6, undo. That's it. Then you want to plot it. We're giving you 2 weeks to do this. I think I'm going to ask Dr. Groves if we have. I want something from you next week, because if you just wait till the last day, programming is at the last minute is almost more cruel than proofs at the last minute. It's like not fun.
I thought the code was due this Monday.
Yeah, let's make it that you have to have something done by this Monday. I'll give you I think, like I said, I was kind of thinking as I was driving up this morning, like, I'm not being that hard on you guys because I'm used to working in the first stage where you have to slow them down the other direction. Let's do something else for the Monday that you actually have code written down. Maybe it doesn't run. Get AI, and then you rerun that. Right? So you probably need a little more support than just booting you out of the nest and saying, do it. Colonel Clark will do that. My son said he learned a ton from Colonel Clark because he was just booted out of the nest. Just do it. Which is good. Like just like throwing you in the middle of a swimming pool saying, learn how to swim. And all the students did it, so. Okay, are there any questions on this? So yeah, don't do nothing because you will be painful. You won't be able to get anything to run. Never once the first time. Okay, I only have 5 minutes left, but I do want to show you something with Taylor series. Gives you kind of an idea where it comes from. If you ever ask anybody what should be left out of a calc class, because things have more things have gotten into a calc book than have been taken out. So right now your Stewart, one of the reasons it's online is because it's huge. You see, you pack that thing around, you'll have your workout for the day. And so one of the things that shouldn't be taken out is a Taylor series, because that is one of the things I always look at it as I'm an applied mathematician. I use this stuff. What have I used over my lifetime in differential equations and those kind of areas? Taylor series. I actually inverted that, and I would start with Taylor series first in a class on calculus. You learn derivatives and then go straight to Taylor series because it's a model. Can I get you close the laptop? It's a model of a function, and in this case, it's an unknown function. It's the y of t you're after, and you use it also for interpolation. Use it for all kinds of stuff, and so it's actually useful. And I see Georgia Tech students always using it for stuff, so it's something that's really important. So if I have y of t around tn 1, then the first thing I have here is y of tn plus so see, I'm writing it down without even with no notes. It's because I know it. It's because I had to use it. I'm going to put approximation here. That's a Taylor polynomial of degree n. Anytime I write something up here without notes, it's not because I'm infinitely smart. I used to think that with my professors. They're so smart, they don't even need notes. It's because I used it over and over and over again. I'm not just taught it, I've used it. So that should give you a little bell should be ringing. Should be using n's here, right? Should be using k's. So that's a kth polynomial. What you're doing is you're taking an unknown function and you're modeling it by a polynomial. And you know from class, I don't know if they told you this, but the more you add to it, the better of an approximation you get, under the assumption that the Taylor series converges and does what it's supposed to do. So in series and sequences and the calc classes, you probably did ratio tests. Ratio test is the only one that's really, really important because that's what you use to show your Taylor series and the interval of convergence and all that stuff. So you did all that. So let's suppose it all works and y of t has a Taylor series. That's what it would look like. If I want to now make a numerical method on this thing, then all I have to do is say, okay, I want to now make my t n equal to t, or my t equal to tn plus 1. So this is the n plus 1, and y of tn is going to be f. What's tn plus 1 minus tn? H. Ah, there's Euler's method right there. The first order. So that's if I just stopped here, my error term would be a polynomial of degree 2 or higher. All that stuff would be to the right. So that's what we call order 2 error. So that Taylor series, that that Euler's thing has order 2 error. And I will explain in a second. If I went to the cube or the second term, I get h squared f double prime of tn yn divided by 2 factorial. And I'm actually leaving out the fact that I need a Taylor series in 2 dimensions. That's sometimes covered in real analysis, but I don't think we're going to get there. So this would be, if I had something that went out this far, then my error term would be a cubic one. Everything after would be a remainder. The remainder tells you the error that you have between your actual and your Taylor approximation. So that's where these order 4, order 3, they're coming from. So the Runge Kutta, you see that 2? That's where the halves and stuff come from. And then the third one would be h cubed divided by 3 factorial, which happens to be, what's 3 factorial? That's where your 6 comes from. Because, you know, if you're curious, it's like, where did these things come from? Third derivative, blah, blah, blah. And these guys come from approximating your f. That's where they come from. So that's where the numbers actually come from, but it's equating coefficients, and the algebra is really nasty. So if I was doing that in class, I would just be writing on the board the entire time and doing the algebra. But that's where that guy comes from. And that's where the error comes from. Colonel Laporte and I just used it in a paper. We're doing an error with the Taylor approximation, and we have, I think, third order error, and we explain why something needs to be sampled at many time points. And this is the error of what it looks like. So I use it. Okay, good. I gave you, I think, hopefully interesting homework.